Okay, hi guys. Today we will be solving this Leetcode problem called maximum product subarray. So the question says, given an integer array nums, find a contiguous non-empty subarray within the array that has the largest product and return the product. The test case are generated so that the answer will fit in a 32-bit integer. A subarray is a contiguous subsequence of the array. So, to be honest, I did try to solve this question before, and on my first attempt, I got it wrong. It's because when I was implementing my logic, I was only using example 1 and example 2. I did not think about the scenario where there would be multiple negative numbers. For example, on the example 2, it does have multiple negative numbers, but the thing is, we do have zeros. So anytime you multiply 0 with any number, it will give us 0, right? So in this case, the negative value was not taken into consideration. So for my first attempt, I tried to solve it the way I solved the sum product. But in the sum product scenario, even if you add -2 to negative whatever number, it will still be negative. But in max product, it would not be negative, right? So if you do -2 times -2, that would be 4, because negative times negative, it will be positive. So I had to look through some YouTube video and do some research to figure out if I can find a way to solve this problem. And I did find some pretty good solution, but I felt like I needed a little bit longer to truly understand how to answer this. So I'm making this video to explain how I would go about solving this problem. So I'm hoping that it helps you guys. Anyhow, sorry, my neighbor is being a little bit loud. I think he's fixing his car or something. But what we can do for this problem is try to keep track of our minimum value and maximum value and global value as well. So by minimum value, I meant let's give an example. Let's say I have -2, I'll have 4, and -2 again, and 4. So let's say this is our array, right? So what we need to do is keep track of two situations. So one situation would be when we multiply -2 with 4. And our another situation would be not keep -1, -2, but just keep 4 as our starting element. Because in this problem, we are looking for subarray, right? So we do have option to ignore and start with another element if we think that that one is higher. So what I would do is, let's say, keep track of max, min, and global, right? Global would be like overall large value among all those, or among the max value. So initially I would want to start with -2 for all of them. So that would be this element, right? So we would start with that. So what we would do is take our two options we have. Either we can multiply -2 with 4. That would give us -8. Or we would just take 4. We would just ignore the -2 and just start with 4. So in that case, we have 4. So in this one, we would keep -8 as our minimum, and we will keep 4 as our maximum. So after that, we would have to check if the max value is greater than global. And if it is, then we will replace the global value to the max value, which is 4. And we'll do the same thing again. So now we'll do 4 times -2, which will give us -8 again. And then we'll do -8 times -2. Sorry, my alarm for my dog's medication. So -8 times -2. Now we would get 16, positive 16. So that's why it was important for us to keep track of the min and the max, because if we had just ignored the min and just kept the 4, we would not have gotten 16 as a value, because we would have just ignored the -8 because it's the minimum value. So in this case, we would compare 16 to -8. So that means our max value would be 16 and our min value would be -8 again. Okay, so now we would check, is 4 greater than 16? It's not, so we'll replace the global value with the max value, so we would say 16. Okay, so now we'll do it again. So we would check if, all right, did I go through that again? 4 times 4. Okay, so now we would do it again. So it'll be 16 times 4. How much is that? So 16 times 4, that would be 64. So it'll be 64, comma, so it'll be -8 minus 4. That would be 32, I believe. And now we would check if, so 8 minus 34. Now we're checking if 64 is greater than 32. It is, so we replace max to 64 and min will be 32. So in this case, since 64 is larger than 16, our global would be 64 and we would return our global at the end, which is 64. So hope that makes sense for you guys. So the whole thing about this product, this solution is different than the sum product solution, is because in some product we're only keeping track of max in a way, because we're seeing which would give us the max value, but in here we would have to keep track of minimum value as well. So let's start coding this. So for this one, we would just say let max equals to nums 0, let min equals to nums 0, and also let global equals to nums 0. So I'm just initializing them, all of them, with the same num. Okay, so first we need to think about the situation where num's length is 1. So we can say if nums.length equals to 1, then we can just return nums 0. Okay, so that would be our edge case. So what we would do is we would go through a for loop, say let I equals 0, I is less than nums.length, I plus plus. So in this scenario, we need to start with 1. It's because we have already assigned 0 to the max, min, and global 0 element. So we don't want to iterate over the same element and compare them again. Okay, so here, like we said, we'll take the minimum value. So actually, let's start with max. So what we would do is we need to find the maximum value between max times nums I, max times nums I, sorry, this one would be min, and also nums I. So there could be a scenario where the element itself can be higher than the min and the max value. So that's why we need all 3 of them. So in the min, it will be same as this one, but instead of mat.max, it will be max.min, right? But for the min situation, we want to compare the original max. Since we did the max calculation on the top already, on the min, we are actually using the max, that's the value of this one, but we need to use the original one. So in order to do that, we actually need to save the original value as a temp. So we can just say max times nums I and replace this with temp. So the reason we are doing this is because we don't want to overwrite the original max value. But once we calculate the max and find the max between all these 3 elements, it effectively replaces the old max value with the new max value. But in order to get the true min value, we actually need to get the old max value to compare with other 2 elements. Okay, so once we do that, like we said, if the max is bigger than global, then we need to change the global into max, right? Like we did for this walkthrough on the top. So in this case, what we would do is say global equals to mat.max and do max global. And then at the end, we are basically returning the global. Okay, so hope that makes sense to you guys. So the code is basically saying what we had initially talked about, right? So we assign the min and max and global with the initial element, like the first element of the num, which is -2 here. So these would all be -2 for now, and then we would basically pick the lowest value for the min. So this these value, like how we came up with it earlier by just multiplying and choosing the less result, and then the max would be picking the highest value, and then the global will be picking the max value among the max array, I guess max value. Anyhow, let's try to run this and see if this works. Okay, let's do run. Okay, we're getting the right answer. Let's try to submit it. Yeah, so we are 84% faster than the other submission. Yeah, I mean, it is a bit confusing, so just try to walk through the examples like I did here, and it would make much more sense to you, because I was confused as well and I had to go through multiple examples. But hopefully that makes sense to you guys, and I'll see you guys in the next round.